Okay, it's a video on Chapter 4, Sections 4.1 and 4.2. Chapter 4 is covering matrices. A matrix is a way of organizing and working with data. And we can talk later about what type of data that is or where it comes from, but you basically take a bunch of numbers and you put them in a box. That box is called a matrix. So this right here has a dimension of 3 by 2. This is a 3 by 2 matrix. That's its dimension, because it has 1, 2, 3 rows and 1, 2 columns. It's a 3 by 2 matrix. All matrices have a dimension, and it always goes row column. So this is a 2 by 4 matrix. There's 2 rows, there's 4 columns. Its dimension is 2 by 4. We can find the individual cells, individual spots of the matrix, which are called cells. So this right here is the first row, third column. So that's called A sub 13, row 1, column 3. And this is the second row, first column. So A sub 1, 2 would be negative 2. We want to grab like this one right here. This is A sub 3, 1. Sorry, 2, 3. A sub 2, 3 is 1. That's how we can tell which cell we're dealing with. As I said before, everything with matrices goes row then column, row then column. So here we have another matrix, and this just has variables in it. So this is A sub 1, 1, A sub 2, 1, A sub 3, 1, and it's row, column, row, column, row, column. This is a 3 by 3 matrix. And a 3 by 3 matrix we call a square matrix because the rows and the columns have the same size. Square matrices are important, and we'll see why later. That takes care of 4.1. 4.2 is just adding and subtracting matrices. So here I've defined matrix A and I've defined matrix B. Since A is a 2 by 3 and B is a 2 by 3, we can add or subtract them. You can only add or subtract matrices that have the exact same dimension. So if I want to do A plus B, I do matrix A plus matrix B and match up the spots, the positions. So I'm going to do 5 plus 0, and I just add up those top left spots. That gives me a 5. 1 plus 1 is 2. 3 and negative 3 is 0. 9 and negative 2 is 7. 1 and 5 is 6. Negative 2 and 8 is negative 6. So you just add up the corresponding cells in each matrix. This right here has a multiplier in front. When there's just one multiplier in front, a single number, we call it a scalar. And what that's going to do is take all of matrix A and make it 3 times bigger. So instead of having 5, 1, 3, 9, 1, 2, I get 15, 3, 9, 27, 3, negative 6. Everything just got tripled by the scalar. It was 3 times bigger. If we have capital letters without the little brackets around them, that still means matrix. You don't have to have the brackets around to mean matrix. That's just what the capital letters tell us. So 2A minus B would be 0 to negative 6. Negative 4, oops, I'm sorry, that was 2B. I'm going to find 2A. 2A would be 10 to 6. 18, 1, negative 4. And subtracting B, which is 0, 1, negative 3. Negative 2, 5, 8. And I get subtraction is a little bit tricky. You've got to be very, very careful about this negative sign right here. I want to do 10 minus 0. Well, in that case, 10 minus 0 is obviously 10. Then I'm doing 2 minus 1. 2 minus 1 is 1. Let's do my red color. But here's the one we have to be very, very careful. This is 6 minus negative 3. Well, 6 minus negative 3 is really 6 plus 3, so that becomes a 9. That's the one that people mess up, is when you're subtracting a negative. So 18 minus negative 2 is really 20. 1 minus 5 is negative 4. And then negative 4 minus 8 is negative 12. If your matrices don't have the same dimension, you can't add them up. That's a 2 by 2, that's a 2 by 3. This just cannot be done. You cannot add matrices that don't have the same dimension. That's what I was saying right here. You can't add matrices that don't have the same dimension. I've already gone over that. Here, 3 things to be aware of. Matrix addition is commutative, which means I can switch the order. A plus B is the same as B plus A. It's associative, which means I can add things up in whatever order I want. I can do the parentheses here and add the B and C first. And I can distribute scalars. I can't distribute other matrices when we multiply with matrices. We'll talk about that later. But I can distribute scalars, so it's distributive. Okay, last slide, almost done. Here I want to try and find x, y, and z based on this equation that I'm given. I'm given a matrix equation where I have one matrix and another matrix added up, or in this case subtracted together. I'm going to see what they equal. Well, if I want to find this x right here, this would be 6 minus negative 1 equals x. So it becomes 6 plus 1, so x equals 7. I want to find this y right here. This is y minus negative 1, and that has to equal 10. So I'm doing the corresponding spots. So this was the middle right spot, middle right spot, middle right spot. Y minus negative 1 equals 10. So y is obviously 9. Finally, I want to find z. This is going to be the bottom right spot, bottom right spot, bottom right spot. Negative 1 minus z equals 0. Add a 1 to both sides. Z is negative 1. Okay, that takes care of the first 2 sections. If you have any questions, please feel free to ask. Thank you.